Okay, so these are obviously a step up. Not a huge one though. It's not that bad, I promise. So for the first one, the circuit on the left, given that the ammeter in figure whatever reads 1 amp, which is this one right here. This is reading 1 amp. You can write that down actually. It's pretty valuable information. Let's go 1. My bad. Technical difficulties. Okay, so this is going to be 1 amp. So we know that 1 amp is flowing down this way. So the 1 amp is coming that direction. And what we also know is that parallel resistors have to have the exact equivalent voltage. So we know that, and we can label this as the current come through here can just be like I1, and we can label the one going through here as I2. So that's an I. It's I2. So we have I1 flowing through here. We have I2 flowing this way, and we know that 1 amp is equal to I1 immediately because this is what the ammeter is reading. So we can say, okay, well then 12 times that 1 amp is equal to, and because the voltage, we're just using Ohm's law here, so we're saying the 12 ohms times the 1 amp that this is reading is equal to the 6 ohm resistor times whatever I2 is. And this is going to give us, this is going to solve for I2. So once we do that, we'll know the current that's flowing down here, and we already were given the current that's flowing through here. So obviously I2 is going to be equal to 2 amps. And now we know that I1 here is 1 amp, I2 here is 2 amps. And we also know that current, when it combines, so that means that the current flowing here, once they combine, is going to be 3 amps. It's going to be simply I1 plus I2 is equal to I, and we'll just label this as I3. And I3 continues to here, and so forth. It keeps going. So now we've discovered that 3 amps is what's flowing through the 2 ohm and 4 ohm, and then it splits between the 12 and 6 ohm. So now we know what this is looking like, but the question is asking what is the voltage source essentially? Because it's asking for the EMF, which is just the voltage, and it's asking what the voltmeter is going to read, and the voltmeter is simply measuring the battery. So what it's really asking is it's asking what the voltage is here. To get that, we now know the overall current is 3 amps, so the overall current for the entire circuit is going to be 3 amps. But what we don't know is the R total, which we still need to find that. So I was like R total. Well, that's what we need. What is our total? Well, it's simply going to be 4, because 4 is right here, 4, plus 2, 2 is right here, plus, well, what happens here, they're simply in parallel. We're going to use that parallel equation. We're going to do 6 times 12 over 6 plus 12. That's the equation for two parallel circuits. You multiply the top and add the bottom and divide them. And you'll find, even if you still want to do the 1 over R1 plus 1 over R2 thing, if that's what you're more comfortable with, you'll get the exact same answer, I promise. So if that's what you want to do, by all means. But this is going to give us, for the R total is equal to 10 ohms, not 12. Why do I write 12? 10 ohms. So you can get 4 plus 2 is 6. 6 times 12 is 72. 72 divided by 18 is going to give you 4. So, and that gives you 10 ohms. So now we know that we can use Ohm's law again. We go V is equal to that 10 ohms there, IR, 10 ohms times the amps, which is 3. And you're going to get 30 volts. And, hopefully that's correct. Okay, now this is just the next one. It's asking you how much current passes through each lamp in figure whatever. The battery has negligible internal resistance. So this focuses just internal resistance. So it's important to remember that in real life, things aren't perfect. So these are really just, these are lamps, and the resistance of whatever material or whatever is going on inside the lamp is equivalent to 4 ohms here, 3 ohms here, 6 ohms here. These aren't actual resistances, but we're treating them like resistances to solve this. And then 6 volts, it says its internal resistance is negligible, so you don't have to worry about whatever inconsistencies are going in the battery, but we do have to worry about the lamps that have 6 ohms instead of being perfect. But essentially, you can treat this the exact same way. It's just the concept that's important here. Yeah. So if we look at this, objectively, you can move. Let's say we slid this 3 ohm. Oh my God! Every time. Let's say we move this 3 ohm down here. Okay, and it was here. It looks pretty obvious that these are in parallel. Maybe you slide that over here, but you can slide this down before a node. Don't let it pass a node, but you can slide this down, and it looks pretty obvious that they're in parallel. So we can do that same equation. We can say 3 times 6 over 3 plus 6. That's going to give you 2 ohms, right? 6, 18. Yep, divided by 9. That's going to give you 2 ohms. So we know that these combined are equivalent to a series resistor of 2 ohms. And we also know this is here as well. So we can say, and we're essentially transforming the circuit. So we're replacing all of this with a simple singular resistor that leads straight into the 4 ohm resistor, and then you'll have your battery. And then, yeah. So we're just transforming the circuit here, and then obviously these are now in series, so we can go, okay, well now it's going to be a 6 ohm resistor. And the reason I'm doing that is because we're trying to find the current through the most simplified version, because the current through 2 ohm and 4 ohm is going to be the same as the current through this 1 4 ohm or this one here. So I think that's the first step. So it's 6 volts. We have 6 ohms. We have 6 volts. 6 times I is equal to 6 volts. So we can say I has 1 amp of current. And that's your answer for 4 ohms. So for this one, I'm just going to, it obviously doesn't equal 4 ohms, but it's equal to the 4 ohm. That's the current running through the 4 ohm resistor, or the 4 ohm lamp. But now we still have to deal with 3 and 6. What are we going to do there? Well, we know now, after transforming this circuit and simplifying it down to 2 and 4 and solving for the current flowing through this, we know that the current over here is 1 amp, or the current over here is also 1 amp because nothing's changing, or the current flowing into this node is 1 amp. I keep writing I amp, but it's 1. I don't know. So all we're going to do here is current division. So if you're, it's the same concept as we did before. It's just going to be, we know that these are in parallel, so the voltage has to be equivalent. So we know that 6 I1, we'll label this I1, and we'll label this one I2. It's flowing through. So we have I1 plus I2. So we have 6 I1 plus, or no, 6 I1 is equal to 3 I2. And we also know that I1 plus I2 is equal to that 1 amp that we got earlier. Because again, that 1 amp is flowing in, it goes into here. So I1 plus I2 has to be equal to that 1 amp that's coming in. And these are just going to be equivalent. And again, in the second equation is described by the voltage and 2 resistors that are parallel have to be equivalent. So we're just using Ohm's law to set those equal to each other. 2 equations, 2 unknowns, and you're going to get that we're going to get 0.33 amps for 6 ohm resistor. Oh, I pressed the button. Stop! And you're going to get 0.66 for the 3 ohm. Okay, you are. Just 2 equations, 2 unknowns. That technical difficulties. Shut it down. I ran my pen's gone. I threw it away. But my mouse still works. Okay, so you're going to get 0.33 amps for the 6 ohm. Once you do these 2 equations, 2 unknowns, 6 I1 is equal to 3 I2. I1 plus I2 is equal to 1 amp. Equation 2 is you're going to get 0.33 for the 6 ohm, which is that I1, and you're going to get 0.66 for the I2, which is good because, again, 0.33 plus 0.66 is roughly 1, and they will have the same voltage. So, perfect.